I got an excellent question from a student asking about new rounding rules. And so I kind of wanted to go over the new rounding rules first so you have an idea of what's going on, and then I'll discuss whether or not we use them and in which situations we use them. So the new rounding rules are this. So previously, if we had, for example, let's say we had 18.5 and 17.5. And we took an average of those two. These two things, this is not to me greater than, this is just kind of pointing in this direction. We took an average of those two. We get an average of 18.0, right? Okay, now if we go ahead and round each of these, so for example, using our old rule, 17.5 and 18.5, 18.5 would round to 19, right? And 17.5 would round to 18, and that's because, again, if it's like 0.5, you round up, and hopefully you've got a pretty decent idea about those rounding rules. Now let's take an average of this. An average of this would be 18.5. In other words, if you took 19 plus 18, you added them up, and divide by 2, you get 18.5. Now let's go ahead and do the new rounding rules. This is old. This is new. If we do the new rounding rules, the new rounding rules say round to even number. So if we have 18.5, the nearest even number you would round to would be 18. And this would round to, therefore, 18. Now let's take a look at 17.5. 17 is not an even number, and so we'd actually round up to the nearest even number, which is 18. An average of 18 is 18. In other words, this one right here, the average of these two, and this one right here, the average of those two are equivalent. When you use the old method, you're constantly averaging higher than it actually is, or you're constantly assuming a number is slightly higher than it actually is. So this is why the new rounding rules are pretty great. They really help eliminate this overall overestimation. All right, so that's cool, but do we use them? Here's a really frustrating part. Let me give you an example. Gen Chem 1, probably about 50% of professors use them. And this is all across the nation. This isn't just your university. This isn't a new issue. And analytical, almost 0% use them because the main analytical book actually uses the old rounding rules. And in basic chemistry, most of the methods I use will use old. Does that mean your time is wasted by knowing the new rules? Hopefully not. And now you won't be surprised when these rules come across in maybe future classes, you might see them. And if you don't see them, I'd be actually a little bit disappointed, but not all that surprised because, again, it takes a long time for things to enter if you watched my discussion on the new rounding rules. So I'm sorry if it's confusing. I can understand that it would be. And basic, you can use either and you'll get away, but I'll pretty much teach with the old rules because the one time I taught with the new rules, people were confused all the way to the end. So I'm just gonna go ahead and continue to teach with the old rules because that allows me to lay the foundation that I'm looking for. And when you get to Gen Chem, you can have these ideas still in mind and still succeed. So I apologize if it's confusing. I understand that it is, but I just really I don't want to limit your mind to just thinking one way. And now you know why the new rules are the way they are. With that being said, to answer your original question that I got, I think the question was, I'm doing this from memory, I think it's 5,480 plus 5.61 was the question. And we were looking at significant figures. So if you add this up, you get 5,485.61. So when you go ahead and you round, and the only number, the last significant number you know is this 8. as to the tens place. You look at this 8 and you ask, hey, is there a 5 next to it? There is. In this case, you would round up with the old way, or you would round to the even number with the new way. So I would accept either answer as 5,490 or 5,480. But I just want you to be able to see where each of these come from. So I hope that helps, and have a great day.